All right, ladies and gentlemen. So today we're going to start lesson 17 1/10, or lesson 17.1, measures of center, which is our first lesson on data analysis. All right, so the state of Texas expects you all to be able to summarize numeric data with numerical summaries, including the mean and median. And it's on page 45, ladies and gentlemen. All right, so finding the mean. A measure of center is a single number used to describe a set of numeric data. A measure of center describes a typical value from the data set. One measure of center is the mean. The mean, aka the average, of a data set is the sum of the data values divided by the number of data values in the set. Remember, guys, sum means to add, which means that you add up all the data values and then you divide it by the numbers in the data set. So here they give us this example here. Excuse me. Tammy surveyed 5 of her friends to find out how many brothers and sisters they have. Her results are shown in the table. So here, ladies and gentlemen, she surveyed 5 of her friends. And here are the results. All right, so they're telling you guys, or they're step A, letter A, they're asking y'all to model each person's response as a group of counters. So if you all right here, kiddos, this is like the data that she had. So let's say, for example, her friend Amy, she has 2 brothers and sisters, or 2 siblings, which we use a counter for each one of those siblings. So she has 2, we're going to put 2 counters. These 2 tables here, ladies and gents, or sets of data are kind of the same, just represented a bit differently. All right, Ben had 3, so if you count right there, there's 3 counters, and Cal and Don both had 1, and Ava had 3. So now, letter B. Now, rearrange the counters so that each group has the same number of counters. What that means, ladies and gentlemen, here we have 2, we have 3, 1, 1, and 3. How could we rearrange the counters so that they're all even? If you guys can visualize it, we'll get this counter here. We'll move it right there. Get this counter and move it right there. And voila, we will get this here. Well, that's not the best, huh? Well, I don't know if I could. Let's just scratch those off here. So you see, we just focus on that top half there. We just rearrange them so that each group has the same number of counters. So this will just be 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right, so now, ladies and gentlemen, each group now has 2 counters. This value is the mean. This model represents how the mean evens out the data values. It's kind of a little similar to what we did when we were working with division. Remember when we were working with equations and we would have like, 5x equals 20. We would, to get the 5x's, we'd separate them and we'd get the 20 units. Remember, 1 unit with 1 x, 1 unit with another x, 1 unit with another x, and so forth. That's very similar to what we're doing here. All right, so here, now we can do this here, going off the original data. So we're going to ignore this model right here for the moment. Or not this one, I'm sorry. We're going to ignore this one here. And we're going to go based off the original one, which is this right here. And this original one here too, if you want to see it that way. So here we have 2 plus 3 plus 1 plus 1 plus 3. And then if we add them all up, 2 plus 3 is 5, plus 1 is 6, plus 1 is 7, plus 3 is 10. So then that gives us, that's what we should have for the beginning there, ladies and gentlemen. They all equal 10. And that's what we did right there, okay? Which brings us to our next question here. How many data values are in the set? Well, let's find out. When we count them, ladies and gentlemen, we know that there were 5 people because it says she had 5 friends, remember? So how many data values are in the set? We have a total of 5. So we're here to calculate the mean or the average. You find the average or like the total, the sum of all the data values, which was 10, divided by the number of values. There were 5 friends. So 10 divided by 5 gives us 2, ladies and gentlemen. So the average is 2, which is kind of similar to what we did over here when we kind of spread them out there. Spread them out even, okay? All right, so finding the median. Another measure of center is the median. The median represents the middle value of an ordered set. That's a keyword right there as well, ladies and gentlemen, ordered, because you have to place them in order from least to greatest. If, let's say, they would have given us these numbers here in random order, let's say 10, 5, 6, 8, 4. First of all, you have to start off by ordering them in order from least to greatest, okay? Let's keep that in mind, please. All right, so example number 1. A coach records the distances that some cross-country team members ran last week. Find the median. All right, so they're asking us for the median. So write the data values in order from least to greatest, which is what they did for us right here. So now, something that you guys can do, ladies and gentlemen, to find the median here is this. 1, 1, 1, 1. Just scratch them off, like one on each side, until you get to the middle one. Bingo, right there. So which means that this value is the median. Equal number of values on either side of the median, which means, there's 2, 4, 5, 5 on each side, and the middle one that's the median, ladies and gentlemen. So here, reading right there, the median is 7, which is right there. All right, so now the next one here, find the median of these test scores, 87, 90, 77, and so forth. So first of all, we have to start off by what? By ordering the numbers or the data values in order from least to greatest. So, but however here, once we put them in order from least to greatest, if we do what I just showed you guys, 1, 1, 1, 1, we're going to determine that there's 2 numbers in the middle. So whenever that happens, ladies and gentlemen, whenever you have 2 data values in the middle of the data, you have to add both of them and divide by 2. You add both of them and you divide by 2. So which is kind of what they're explaining to you right here. This data set has 2 middle values, which are 87 and 90. The median is the average or the mean of the two values. I'm sorry. So what they did right here, ladies and gentlemen, they did 87 plus 90 and then divided that by 2, and they were able to come up with 88 and 5/10, or 88.5. So the median of this set of data, ladies and gentlemen, is 88 and 5/10, or 88.5. Which brings us to question number 2. What if? Which units are used for the data in A? If we rewrite that, ladies and gentlemen, let's see here. Alrighty, ladies and gentlemen, so I think there was an error here. But I guess what the book forgot to mention is that here in Group A, ladies and gentlemen, the units are in miles. Okay? They're in miles. Well, here, ladies and gents, I know I did say miles, but they didn't really specify. So it could have been miles or kilometers. But if the coach had recorded some of the distances in kilometers and some in miles, can you still find the median of the data? Well, ladies and gentlemen, let's say, for example, if it was 5 miles, 8 kilometers, 10 kilometers, 10 miles, you can't do that. Not unless you convert them all into similar units. Either converting them all into miles or all into kilometers. So, and then once you convert them all into the same units, then that's when you're able to actually order them in order from least to greatest. Alrighty, so moving on here. Charlotte recorded the number of minutes she spent exercising in the past 10 days, which are 12 of those values. Find the median of the data. Alrighty, so I'll give you guys some time to go ahead and do that. First, we have to start off by ordering them in order from least to greatest. They want to order them in order from least to greatest. Then you guys can cross them off from each side, and whichever number is in the middle, that is your median. Which in this case, ladies and gentlemen, our median is 6 and 5/10. All right, because it was 6 and 7 in the middle, so we have 6 plus 7 divided by 2. All right, so comparing the mean and the median. The mean and the median of a data set may be equal, very close to each other, or very different from each other. For data sets where the mean and median differ greatly, one likely describes the data set better than the other. So just depending on what you're trying to compare, or what you're trying to determine or explain. So they're giving us here this example. The monthly earnings of several teenagers are the following. Find the mean. So remember guys, how do you find the mean? You add up all the data sets and then you divide by however many you added. So here it would be, 200 plus 320 plus 275. All right, ladies and gentlemen. So once you guys add them all up, all the values, you should end up getting 2,455. You divide it by the number of values, which were 7. And you guys should get approximately, see that little squiggly lines? That means approximately, which is not exactly equal to, but very close to it. Like you guys should have had this here, 350.71428, and it keeps going. But ladies and gentlemen, when you guys go to the store, remember, our currency goes up to the tenths, hundredths. It goes up to the cents. So you guys need to round up to the hundredths, which you do so by looking at the thousands. If that number is less than 5, then it stays the same. But if it's greater than or equal to 5, then you round up. In this case, 4 is less than 5, so you just take those out there, and that's how they came up with approximately 350.71. Okay. All right. So letter B. Write the data values in order from least to greatest and find the median. So what I did here, ladies and gents, I started writing them down. But for example, when I wrote the number 200, I crossed it out right there. That way I don't get confused with it, and tend to keep, and it just doesn't, it takes away one less number that I have to focus on. That helps me, hopefully help you. So let's do it here too. Here, the median, ladies and gentlemen, is 310. So that is our median. The median, nice. Yeah, 310. So now, letter C. The mean and the median differ. Remember, guys, the word differ is telling us to subtract. Like, what is the difference between both of them? So we know that the median is 310, but the mean was 350. So 350.71 minus 310 is about 40.71. About 40.7, that's exactly, but by about, they're not asking us for an exact answer. So here we could have used 40. And that's how we found a difference here. Now for letter D, which measure of center best describes the typical monthly earnings for this group of teenagers? The mean or the median? Explain. So they're asking us, like, which one do you think would be a better description of the typical, or like what a teenager can expect to earn? Should we use a mean? Should we use a median? What do y'all think? What do y'all think, huh? Compare what the mean is, compare what the median is, and make those comparisons like with the sets of data. Because let's compare the mean. We know that the mean is $350 or $350.71. But if we look at the different values that we added here, how does 350 compare to each one of these here? How does it compare? How does the median, how does that compare to these values, huh? What do you think? Could we say that the typical, like on average, that most of the kids would earn around $350.71 a month? How many of these values are greater than $350.71 or less than? There's only one value that's greater. There's one that's about equal to it, but most of them are less than that. So here, ladies and gentlemen, the best bet to use would be to use the median. And this is what the book suggests. Because the mean is greater than all but one of the values. The median is a more central value, which means, more typical, more what a teenager can expect to earn. Which brings us to our next question. 4. Reflect. Question number 4. Communicate mathematical ideas. And I want you guys to go ahead and do these here, okay? Sorry, because my time's running out because YouTube only gives me a minimum of 15 minutes here. I want you guys to answer the following guided practice and independent practice on your textbooks.